You've opened the performance package, the handout that's attached to the assignment, and by now you've taken a look at the examples, so you know how to multiply a monomial by a binomial by using distribution. And example 1 shows you how to do that. And so read through example 1, read through example 2, and you see that this text uses the box method. You could also use distribution. So let's do x minus 3 times the quantity 2x plus 1. X multiplies both terms in the second binomial, so 2x squared plus x, and negative 3 multiplies both terms in the second binomial, minus 6x minus 3, and then we combine the like terms to get the simplified result, 2x squared minus 5x minus 3. So we get the same result using distribution as we get using the box method. So let's go ahead and apply that to number 1 and number 2. So when you format your take-home for this week, start by copying the example exactly as it appears. Two x times x is 2x squared. 2x times 1 is 2x. And here's the result. Let's look at number 2. Step 1 is to copy the example exactly as it appears. Each term in the first binomial multiplies both terms in the second binomial. So 6x squared plus 21x. And the second term in the first binomial multiplies both terms in the second binomial. Plus 4x plus 14. Combine the two x terms. 6x squared plus 25x plus 14 is the result for number 2. And continue through the multiplication problems. Take a look at number 14. See how there are 3 terms in the second polynomial? Well, each term in the first polynomial will have to multiply all 3 terms, and then there will be a bit more combining of like terms. Take a look at number 15. You probably want to multiply the monomial by one binomial or the other first, then use binomial multiplication. But realize that you only have to multiply this 2 by one of the other factors, not both of the other factors. So I do suggest, as always, that you have your work checked by Wednesday night for a product that's due on Friday. And let me review some of the formatting for factoring polynomials. Example 3 and example 4 express that you're going to use the zero product property. Now this is a big deal, the zero product property. It tells you that whenever you multiply and you get a result that equals 0, it says one of your 2 factors or 3 factors or 4 factors has to be 0. So if you have a multiplication like this one, a times b equals 0, the zero product property tells you that either a is 0 or b is 0 or both. That's the only time you can get 0 as a result in a multiplication. So we use the zero product property when we're solving quadratics. So let's use it for this example. X squared plus 7x plus 12 equals 0. Right now it's in expanded form with addition. If we can change this expanded polynomial into a multiplication expression, then we can apply the zero product property. So in order to do that, I need to factor it. This is what we call changing an expanded polynomial into a multiplied expression. Let's factor it. So x squared plus 7x plus 12. Do you remember that you're looking for factors of 12 that add up to 7? X squared, and that's 3 and 4. And we use those to rewrite the middle term. And we have an equivalent expression. X squared plus 7x equals 12 is the same as x squared plus 3x plus 4x plus 12, but we can factor by grouping now that we have this 4-term polynomial. We do that by factoring the greatest common factor out of the first 2 terms and the greatest common factor out of the second 2 terms. And the result is 2 terms that have one greatest common factor, only the greatest common factor now is a binomial factor. So let's now factor x plus 3 out of the first term and x plus 3 out of the second term. Well, what does x plus 3 multiply in the first term? It multiplies x. And what does x plus 3 multiply in the second term? It multiplies 4. It's a really good idea to check your factor to see if they multiply to get the original polynomial, x squared plus 7x plus 12. Is that the one we started with? Yes. So x plus 3 times x plus 4, I've confirmed that that's the same, has the same value as the original trinomial, only now I can use the zero product property. In order to get this result, 0, from this multiplication, either x plus 3 has to equal 0 or x plus 4 has to equal 0. And that happens when x equals negative 3, right? If I subtract 3 from both sides, I have x equals negative 3. And that happens when x equals negative 4. So I have 2 x values that make this true. So the example they show you uses the box method. I'm using the AC method. I do want you to show all your work when you're doing this performance exercise. And I want to show you one more. Let's do number 25 together. And we're going to do number 25 because the leading coefficient is not 1. We're going to use the same method, factor by grouping, but we want factors of AC that add up to B when the quadratic is written in standard form. So, for the quadratic, 12x squared plus 11x equals 5. Let's subtract 5 from both sides. To get this into a form where we can use the zero product property. So I have a trinomial. It is set equal to 0. If I can change this trinomial into a multiplication expression, I'll be able to use the zero product property. So when I compare my trinomial to my standard form, I can see that a is the coefficient of the x squared term, that's 12. B is the coefficient of the x term, that's 11. And C is the coefficient of the constant term, or the x to the 0 power term, that's -5. I use factors of AC, so AC equals 12 times -5. AC equals -60. I need factors of AC that add up to B. In this case, that's 11. So I'm looking for factors of -60 that sum to 11. So I'm just going to start listing the factors of 60. 1 and 60, 2 and 30, until I get one that has a difference of 11. And I'm looking for a difference because one of them has to be negative in order to have a result of -60. 3 and 20, 4 and 15. Well, there it is. 15x minus 4x equals 11x. 15 multiplied by -4 equals -60. So 15x and -4x are the two I'm going to use to rewrite the polynomial. 12x squared plus 11x minus 5 equals 0 becomes 12x squared minus 4x plus 15x minus 5, still equal to 0. Those two equations are equivalent, only now I can factor by grouping. The greatest common factor in these first two terms is 4x. The greatest common factor in these two terms is 5. So I'm going to factor 4x from the expression 12x squared minus 4x and get 3x minus 1. And I'm going to factor 5 out of the binomial 5x minus 5 and get 3x minus 1. And now I'm going to factor this binomial out of the two expressions and use the zero product property. In order for this product to be 0, either 3x minus 1 has to be equal to 0 or 4x plus 5 has to be equal to 0. So go ahead and get x1 and x2 by solving these two smaller equations. So please format by copying the original problem down and by clearly working all your steps vertically, one to the next.